So in this video, we're going to learn how to solve radical equations, which means we're going to learn how to solve equations that involve radical functions. To solve radical equations, we are going to use a property that kind of undoes the square root operation. The operation that undoes the square root operation is squaring. So squaring is the opposite operation to taking the square root. So to undo the square root, we're going to square, and we're going to use this property that basically tells me that if two quantities are equal, then their squares are equal. In other words, if two quantities are equal, I can square on both sides and the equal sign stays. Okay, so the first step that I'm going to take to solve equations containing square roots, I'm going to undo the square root by squaring both sides. Okay, so let's have our first example here, and this is my example 1, and I have the square root of x plus 1 is equals to 4. So what I'm going to do is I'm going to copy my equation so you can see it here, and let me erase this again. So I have the square root of x plus 1 is equal to 4, and what I'm going to do is I'm going to square on both sides. Okay, I'm going to square on both sides because I really would like to eliminate the square root. So I'm going to square and I'm going to square. Okay, let me put this in red so we can see it better. I'm going to square. So because I'm squaring on both sides and the square root cancels the radical, I'm going to end up having that x plus 1 is equals to 4 squared, and 4 squared is 16. So if I subtract on both sides, I get that x is equals 15. So now I need to check my answer, and to check my answer, I need to check it in my original equation. This is my original equation. So let me write my original equation. Square root of x plus 1 is equals 4. So what I'm going to do is I'm going to substitute my value of x right here. So I have a square root of 15 plus 1, and the square root of 15 plus 1 is the square root of 16, and the square root of 16 is 4, which is the number I had to get. So this answer is definitely correct. Let me go with example 2. So in example 2, I have a coefficient right next to the radical. So what I'm going to do first of all is I'm going to solve for the radical. In other words, I'm going to isolate the radical. So I have a square root of x plus 1, and then what I'm going to do is I'm going to divide by 2 on both sides. So I have that I'm going to divide by 2 on both sides, so I can eliminate these 2 right here. These 2 and these 2 cancel, and I get that the square root of x plus 1 is 12 divided by 2, which is 6. Now that I have the square root, I would like to eliminate the square root. So what I'm going to do is I'm going to square on both sides. So I'm going to square here and I'm going to square here. So remember that the square cancels the radical here, and I have x plus 1 is equal 6 squared is 36. So subtract 1 on both sides, x equals 35. Let me check my answer. Remember, you always need to check. So I have 2 times the square root of x plus 1. That's my equation. You copy your equation, and you are going to substitute the value of x right here on the left. We have x is equals to 35. So I have 2 times the square root of 35 plus 1, and 35 plus 1 is 36, and the square root of 36 is 6, and 2 times 6 is 12, which is the number I had to get. Okay, so my answer satisfies. Let's go with another example. Now I have 1 plus the square root of 4x is equals to 9. Remember that the first thing I need to do is I need to isolate the radical. Okay, that's my first step, always. Okay, so isolate the radical means I'm going to subtract 1 on both sides, and I get 8. Okay, now I need to square on both sides. I need to eliminate the radical. Once I have the radical isolated, all I need to do is eliminate the radical. So let me write it again so you can see exactly what I did. So I'm going to set to the square and set to the second power. Square, square, okay? So remember that this is going to cancel, and I'm going to have 4x, right? The radical stays the same, that's 4x, and that's equals to 64, and then x is 64 divided by 4, which happens to be 16, okay? All right, so x is 16. Let me check my answer. And remember that to check your answer, you add to write the original equation right here, okay? So let me write my original equation. 1 plus square root of 4x is equal 9. Okay, I'm going to put here 16. Okay, so is 1 plus the square root of 4 times 16, and 4 times 16, we know that is 64, and the square root of 64 is 8, so 1 plus 8, and 1 plus 8 is 9, which is the answer I have to get. So this answer satisfies. So let's review the steps one more time. The first step is you isolate the radical. Remember that you need to isolate the radical because you are going to eliminate the radical. The second step is you're going to square on both sides. And the third step is you're going to be checking. Okay? So when you square on both sides, of course, you're going to be solving, right? Okay, so let's go with example 4. Example 4 is really easy. So I have, let me see if I can do this. So I have my radical isolated, so I need to square on both sides. And here I have x is equals 9. Okay, now let me check. Let me see what happens when I check. The original equation is this, and I'm going to put 9 right here. So I'm going to put my 9 here. So I'm going to have, let me just do this in black, a square root of 9, and the square root of 9 is 3. Well, that does not match. It should be negative 3. So what we see is that this x equals 9 is what we call is an extraneous solution. Okay? Is extraneous solution. So an extraneous solution is a solution that solves the square's equation but not the original equation. Okay, so x equals 9 is a solution to the square equation but not to the original equation. Okay, so so we have to remember that when squaring both sides of an equation, you always have to check the resultant solution in the original equation, because a solution of the square's equation doesn't need to be a solution of the original equation. Okay, let's do another example. And now I have my radical is already solved. So let me write it in here so we can see what we're doing. And I'm going to put this to the second power, and I'm going to put this to the second power, and that's why I use my parentheses, okay? So this is going to cancel. I'm going to get x plus 3 is equals to x plus 1 squared, which is x plus 1 times x plus 1, if you remember. So we can use FOIL for this, and that's x squared plus 1 plus 1 is 2x, 1 times 1 is 1, right? Okay, so I have a quadratic equation. How do I solve a quadratic equation? Remember, I need a 0, so I'm going to subtract x and subtract 3, and what I'm going to get is x squared plus x minus 2. Okay, so that's the equation I have. X squared plus x minus 2 equals 0. Okay, so how do I solve this equation? So I'm going to find two remember I need to factor, right? So I need to find two binomials with numbers that multiply give me -2, added give me +1. So what if we take +2 and -1? 2 plus -1 is +1, which is the coefficient of the x, and if we multiply them we get -2, which is the number here. Okay, so how many solutions do I have? X equals -2 and x equals 1. Yes? Okay, so let me check my answers. So I'm going to check the first answer, x equals -2, and I'm going to see if it's satisfied. So I have x plus 3 has to be, the square root of x plus 3 has to be equals to x plus 1. And what I'm going to do is I'm going to substitute -2 in both equations. So I have a square root of -2 plus 3 is -2 plus 1, and that is 3 minus 2 is 1, and this is -1. And we know that this is not true because the square root of 1 is not -1. So this solution we're going to throw out. This is an extraneous solution. Let's go with the other solution. The solution is x equals 1. And again, I'm going to write my equation. The square root of x plus 3 has to be equals to x plus 1. So I'm going to substitute here and here for 1, right? So I have a square root of 1 plus 3 is 1 plus 1. And this is a square root of 4 is 2, and this satisfies, right? So the solution that we have here is x equals 1. Remember that we threw the solution x equals -2 because that solution was an extraneous solution. Okay? Let's do our last example, and remember the first thing I need to do is isolate the radical. So what I'm going to do is I'm going to add x on both sides just so I end up with my radical all by itself. So square root of 5 minus 4x is equals x. Now that I have the radical by itself, what I'm going to do is I'm going to square it, right? Because I need to kill the radical. Okay, so when I square, the radical gets destroyed and I get 5 minus 4x is equals x squared. Okay, so this is a quadratic equation. I'm going to subtract 5, add 4x, and what I'm going to get, I'm going to get a 0 here, and I'm going to get x squared plus 4x minus 5 is equals to 0. So that's my equation. X squared plus 4x minus 5 equals 0. To solve this equation, I need to factor. Let me write the equation right here so we can all see it. So I need to find two numbers that multiply, give me -5, and added give me 4. So what if I have plus 5 and -1? Right? If I add them, I get +4. If I multiply, I get -5. So the solutions are, if I have these two numbers, I have x equals -5 and x equals 1. Okay, now I'm going to check. I'm going to check the first answer, which is x equals -5. Remember, you have to check it in this equation right here. So I'm going to write my equation. Square root of 5 minus 4x minus x has to be equals to 0. Okay, so I'm going to substitute my x equals -5 everywhere, and I'm hoping that I get here a 0. Okay, so here it goes. Square root of 5 minus 4 times -5, right, minus -5, and let me see what that is. This is right here is -20, so it's 5 plus 20 plus 5, so this is a square root of 25 plus 5, which is 5 plus 5, right, and 5 plus 5 is 10. Well, 10 is not equals to 0, right? So this equation is extraneous. We're not taking that equation. Let's go with the others. I'm sorry. This solution is extraneous. We're not taking that solution. Let me go with the other solution. X equals 1. Okay? So I'm going to write my equation and I'm going to substitute my solution. My solution is x equal 1 and I'm going to substitute it right here and right here. Okay, so let's see what we get. 5 minus 4 times 1 minus 1, which is the square root of 5 minus 4 times 1 is square root of 5 minus 4, right? Minus 1, and this is square root of 1 minus 1, square root of 1 minus 1, square root of 1 is 1, minus 1 is 0, and this is exactly the number I have to get so the equation is satisfied. So the answer to this equation is x equals 1. Remember, we had to draw the solution x equals negative 5 because the solution was extraneous. Okay, so what do you do when you have to solve, when you are solving radical equations? You have to isolate the radical, you have to square both sides to eliminate the radical, you have to solve the resulting equation, and you have to check the solution in the original equation. You are looking for extraneous solutions. If the solution that you found in 3 does not satisfy the original equation, then you need to discard that solution because that solution is extraneous.